In this video, I want to talk about another technique for evaluating limits when direct substitution and factor and cancel techniques do not work. So let's look at this example. Here we have the limit as t approaches 5 of 1 over t squared minus 4t minus 5 minus 1 over 6 times t minus 5. Our first inclination should always be direct substitution. But if we try to substitute 5 in for t, we end up with 1 over 0 minus 1 over 0. Because we have division by 0, that still presents a problem for us and leads us to believe that maybe the limit is undefined. But that's not the case. So our next inclination should be, because these are both fractions, that maybe we should factor and cancel. But we can't factor and cancel because the numerator of both of these fractions is a constant, 1. So factor and cancel won't work here either. But anytime we're trying to find the limit of a sum or a difference of two rational functions, we can always try finding a common denominator and combining the two rational expressions. So let's do that. To find a common denominator, let's first make sure that both of our denominators are in factored form. The factored form of t squared minus 4t minus 5 is t minus 5 times t plus 1. And our other denominator is already in factored form. So now from the factored forms of these denominators, let's find our least common denominator. We know that each factor in the factored forms of our denominators must be present in the least common denominator. That means that our least common denominator must contain a factor of 6, it must contain a factor of t minus 5, and it must contain a factor of t plus 1. So our least common denominator is 6 times t minus 5 times t plus 1. To write our first fraction as an equivalent fraction with the least common denominator, we notice that the only factor that this denominator is missing is the factor of 6. So we multiply the numerator and denominator of this fraction by 6. And that gives us 6 over 6 times t minus 5 times t plus 1. Now let's do the same thing for the second term. We notice in the denominator of this fraction, the only factor missing from the least common denominator is the factor of t plus 1. So we multiply the top and bottom of this fraction by t plus 1. And that gives us minus the sum t plus 1 in the numerator over 6 times t minus 5 times t plus 1 in the denominator. Now we have a common denominator and we can combine these two fractions. That gives us the limit as t approaches 5 of 6 minus the sum t plus 1 all over 6 times t minus 5 times t plus 1. Simplifying the numerator by distributing the minus to the t plus 1 gives us 6 minus t minus 1 in the numerator. Combining like terms in the numerator of the fraction gives us the limit as t approaches 5 of 5 minus t, and all of that is still over 6 times t minus 5 times t plus 1. Now at this point, since we've found a common denominator and combined our terms, we'll try to find the limit by using direct substitution. But when we do that, we notice that we get 0 over 0 indeterminate form again. So we're not done yet. So the question is there a way to simplify this fraction further so that we don't have 0 over 0? If we look closely, we'll see that we can factor a negative 1 from the expression in the numerator of the fraction to get negative 1 times t minus 5. And now we see that the t minus 5 factor in the numerator will cancel with the t minus 5 factor in the denominator. And that's the factor that was causing our trouble. Because as we have t approaching 5 in the denominator, that factor of t minus 5 was always going to make our denominator 0. But now we'll be able to cancel that factor out. And by doing that, we cancel out the factor that was causing our problem. So now we have the limit as t approaches 5 of negative 1 over 6 times the quantity t plus 1. Now let's try direct substitution again. Substituting 5 in for t gives us negative 1 over 36, and that is our limit.